Grant Dower, and this is Physics 2212 Lab 2. The introduction. The purpose of this lab is to use charged tape to compare the point charge and line charge models by separating the tape into segments and treating each segment as a point charge. In doing so, determine a more accurate quantity for the charge on each tape. Some fundamental equations and laws that are needed for this experiment are Newton's first law. We will use this law to record the gravitational force exerted on the tape. Coulomb's law. We will use this to observe and measure the electric force that each tape exerts on the other, and superposition, which we will use to add up the electric fields from each point charge within the line charge to determine the net electric field. And some assumptions that are necessary for this experiment are that each piece of tape will be modeled as a point charge when using Coulomb's law. Air resistance is negligible, both tapes will have the same charge, and the charge will be equally distributed along each piece of tape. Experiment details. Step 1, just two neutral pieces of tape called U-tapes, and they are ripped off a base tape that is stuck down onto a table, giving a charge to each tape. Step 2, observe interactions between the U-tapes and other objects to determine the sign of U-tape charge. Tape one U-tape across a gap to create a bridge. Bring the second U-tape close until the bridge tape starts floating from being repelled by the other tape, and measure the separation distance between the gaps or the tape when the bridge is floating. System in this experiment will be the bridge tape, tape B in the diagram. The surroundings will be the tape being held by the bridge below the bridge tape, tape A. And the initial conditions are that the only force initially acting on tape B is the force of gravity. So for the results in my experiment, I got the charge on each piece of tape to be about 2.84 times 10 to the negative 8th coulombs. The electric force equals the gravitational force, which equals about 2.069 times 10 to the negative 3rd newtons. And the superposition of a line charge allows for a much more accurate value for the charge on each tape as opposed to a singular point charge. My GlowScript code, it creates all the physical constants. Here's the mass of the tape that I had, and this is the charge determined on each tape in the first lab. This is the length of the tape distance, and this is just a function to create the electric field. This is a function that creates the line of charge, and this function just creates the tapes. So the GlowScript code, this calculates the electric field and electric force, and this shows the net electric force and gravitational force, and this is the model that the code produces. The magnitude of the electric force, 4.87 e to the negative 4th newtons, gravitational force, 2.069 e to the negative 3rd newtons. And as you can see, this is not correct. Gravitational force equals electric force, and this is due to the incorrect value determined in lab 1. So in order to determine the correct value of the charge, you get this equation, which is just the E field of a line charge, and then multiply it by Q, which is just the charge of the other tape, and then set it equal to the force of gravity, solve for Q, and I got 2.69 times 10 to the negative 8th, and using this value for my code, it produces a much more accurate value for the electric force. It is much closer magnitude to the gravitational force. In order to determine the actual charge on each piece of tape, I did some trial and error and determined it to be 2.836 times 10 to the negative 8th coulombs, which provided a much more accurate electric force compared to gravitational force. Conclusions: the line charge model is much more accurate than the point charge model used in lab 1. Some sources of error were that the tape was not infinitely divided up into small sections with charge, and my handling of the tapes could cause them to lose charge, and the charge on each tape may not have been equally distributed across each tape. Regarding the first one, comparing the point charge and line charge models, the point charge gave me an answer for the charge in each tape as 1.37 e to the -8th coulombs, while the line charge gave me an answer of 2.836 e to the -8th coulombs, which is a significant difference of 51.47%. The single charge model proved to be very far off the actual value of the charge on the tapes, while the line charge model is much closer to the actual value of the charge on each tape. And why do the estimates differ and which one's more likely to be closer to the real value? Superposition allows for a much more accurate value for the electric field produced by the tape because it divides the tape into segments of charge and adds up the electric fields produced by each segment. And the new value from this lab using a line charge is much more likely to be the real value due to superposition.